You know, in the world of software development, we spend so much time trying to create perfect logical order. But what if the best way to find bugs is to inject a little bit of chaos? Today, we're going to demystify random testing, a fascinating method for finding the problems you didn't even know you should be looking for. So, here's our game plan. First, we'll dive into what this whole unsystematic approach is really about. Then we'll see how it actually works, weigh the pros and cons, cover some common mistakes you'll want to avoid, and we'll wrap it all up with a handy little acronym to make sure it all sticks.
All right, let's get into it. The unsystematic approach. This is what makes random testing so interesting. It's really about letting go of the perfect plan and just embracing a bit of chaos to see what shakes loose.
I mean, think about it for a second. The most annoying bugs, the ones that drive you crazy, are almost always the ones you just can't predict. They pop up under these weird, unexpected conditions. So the real question is, how do you even start looking for something like that? Well, this is the exact problem random testing tries to solve.
So what is it exactly? Well, you know how most testing works, right? It's all about carefully planning your attack, checking what happens if a user types in 0 or a ridiculously long name. Random testing is basically the polar opposite. You define a range of possibilities, what we call your input domain, and then you just start throwing random things at the wall to see what breaks.
And this is a fantastic way to picture it. Seriously, you're not trying to be clever or logical. You're trying to simulate the beautiful chaos of a real user, someone who might accidentally do something completely nonsensical. The goal here isn't precision, it's to see what happens when things get a little messy.
Okay, so how does this actually work in practice? It might sound like pure, unadulterated chaos, but believe it or not, there's a method to the madness. Let's break it down into 4 pretty simple steps.
First, you define your playground. That's the full range of all possible inputs. Step 2, you randomly pick your inputs from that playground. Easy enough. Third, you run the software using those inputs. And finally, and this is the really important part, you check if the outcome actually matches what you expected to happen.
Let's make this real with a simple example, an age field. The valid inputs are probably numbers between, say, 1 and 120. A random test might throw in a perfectly normal age like 42, but it's also going to try crazy stuff, invalid inputs like -5 or 150, or even just random text. The key here is to see if the software accepts the good stuff and, just as important, that it doesn't totally crash and burn when it gets the weird stuff.
So, we know how it works. But is it any good? Like pretty much any tool out there, random testing has its pros and its cons. So let's take a look at the trade-offs.
The biggest pro is that it's super cheap and easy. You don't need a team of experts to come up with test cases, and it's fantastic at finding what you might call the stupid bugs, the ones that happen when a user does something totally unexpected. But on the flip side, you can waste a lot of time on tests that are kind of pointless, and it's probably not going to find those really clever bugs. You know, the ones that only show up when you do things in a very specific, complex order.
Now, to get the most out of random testing, you really need to know what not to do. So let's run through a few common mistakes to help you steer clear of them.
The biggest mistake, by far, is thinking random testing is some kind of magic fix-all. It's not. It's a fantastic way to shake out a bunch of bugs, for sure, but it is absolutely not a replacement for more structured, thoughtful testing. Think of it as one tool in your toolkit, not the entire workshop.
All right, mistake number 2. The quality of your random tests comes down to one thing: how well you define that input domain. If you don't give your system a good, relevant pool of data to choose from, you're not going to get good tests out of it. It's the classic case of garbage in, garbage out.
And finally, this is a big one. Running the tests, that's the easy part. The real work is in the analysis. It's easy to spot the obvious crashes, but that's just the tip of the iceberg. The really dangerous bugs are often hidden below the surface. Things like subtle data corruption or weird performance issues. If you're not really looking for them, you will miss them entirely.
So, how in the world are you supposed to remember all of this? Well, we've got a simple acronym that sums it all up quite nicely.
Just remember RANDOM. R is for randomly selected inputs. A is for arbitrary test cases. N is because it needs no special intelligence to get it set up. D is for a great dependability check. O because it's often cheap and fast. And M, well, M is to remind you that it misses those complex logical bugs.
At the end of the day, random testing isn't the most sophisticated tool you can use. It's not. But it is a practical, affordable first step. It's a fantastic way to just shake the tree and see what bugs fall out.
So I'll leave you with a final question to chew on. If it's truly random, if we're giving up precise control and just embracing chaos, are we really testing it all, or are we just getting lucky? What do you think?